Welcome back to The Explainer. If you're gearing up for the Ipmat exam right now, honestly, I know exactly what you're feeling. The pressure is completely overwhelming, the clock is ticking, and that quantitative section, it can sometimes look like it's written in a totally alien language. But seriously, take a deep breath. Today, we are focusing entirely on working smarter, not harder. In this high-yield explainer, I'm going to show you exactly how to conquer some of the toughest questions this exam is going to throw at you. Our goal today is super simple: to prove to you that pattern recognition beats brute force calculation every single time. Okay, let's dive right into this.
So here is our roadmap for today's explainer. We're going to tackle number theory, algebra, geometry, quadratics, and coordinate geometry. All right, first up, number theory, separating the series. We're kicking things off with a pretty intimidating infinite series challenge, straight from the Ipmat Indoor 2025 exam. Here's the deal. You're given that the sum of 1 over n squared from 1 to infinity equals pi squared over 6. And your task? Find the sum of 1 over the odd denominator squared. Now, do me a favor. Literally hit pause on this explainer right now. Take a deep breath. Just look at the terms and see if you can spot the pattern yourself before we move on. Okay, so just to get you comfortable, this is what that monster actually looks like on test day. Seeing the official formatting is absolutely crucial because half the battle is just not letting the typography completely freak you out. I mean, it looks super complex with all those infinity symbols and pi squared, right? But the underlying logic, it's actually surprisingly straightforward. So let's walk through our attack plan. I like to use what I call the laundry analogy. Think of that original series as just a big mixed pile of laundry. To solve this, you basically just need to separate your lights and darks, meaning we split the series into odd terms and even terms. If we just pull out the even terms, 1 over 2 squared plus 1 over 4 squared and so on, we can factor out a 1/4 from all of them, and what's left inside the parentheses, it's literally the exact original series. So the even sum is just 1/4 of pi squared over 6. To find the odd sum, we just subtract that even portion from our total. Boom, done. So here is the crucial takeaway: odd-even separation. Whenever an infinite series involves alternating or sequential odd and even terms, try splitting the original series. Spotting this trick is a total game changer. It'll save you minutes of absolute panic and messy calculations. It's a pure test of pattern recognition. Moving right along to number 2, algebra, the balancing scale. Let's explore this next one. Suppose A, B, and C are real numbers. The maximum plus the minimum equals 15, and the median minus the mean equals 2. We need to find the median. Now, pause and look at these variables for a second. At first glance, it totally looks like we need to find 3 separate variables, right? Like x, y, and z. But do we really? There is a massive trap here versus a really slick shortcut. Trying to find the exact values for x, y, and z? That's the brute force trap. You're just going to burn precious exam time. Instead, use the shortcut. Think of it like a balancing scale. You don't need to know the exact weight of every single item. You just need to know how they balance against each other. If our numbers in increasing order are x, y, and z, then x plus z equals 15. The median is y, and the mean is x plus y plus z, all divided by 3. If you just plug that 15 into your mean equation, you can solve directly for y. And that leads us to our core concept here: mean-median manipulation. The trick is noticing the relationships between the minimum, maximum, and mean to isolate exactly what you need. In this case, it gives us a median of 10.5. Just remember, for the Ipmat, if a problem looks like it has way too many unknowns, I promise you, there is almost always a hidden relationship just waiting to be exploited. All right, number 3, geometry, the secret bridge. Now here's a highly conceptual one. In triangle ABC, side AB equals AC, which equals x. The angle ABC is theta, and the circumradius is y. We need to find the ratio of x to y. Before jumping in, pause the explainer and really ponder this. How in the world could side lengths possibly connect directly to a circumradius? What's the link there? So looking at the official problem layout from the exam, the very first thing that should absolutely jump off the page at you is that because AB equals AC, we're dealing with an isosceles triangle. That right there is your entry point. Let's break down the attack plan for this one. Step 1, recognize its isosceles. Step 2, because it's isosceles, if one base angle is theta, the other one has to be theta as well. And that means the top angle, angle A, has to be 180 minus 2 theta, right? Now for step 3, the grand finale, we apply the extended sine rule. Now the side opposite angle A isn't actually what we're looking for. We are looking for x, which is opposite the angle theta. And this brings us to what I call the secret bridge of geometry, the extended sine rule. A side divided by the sine of its opposite angle equals twice the circumradius, or 2r. Listen, the very second you see a side and a circumradius mentioned in the same breath, you must think of this formula. It's basically a magic bridge that instantly links side lengths and angles directly to the circumradius. It hands us the answer so simply and elegantly. Moving on to topic 4, quadratics, the recipe shortcut.
All right, take a deep breath for this one. We're moving into quadratics. And this next problem, it's a solid 4-star difficulty. The prompt tells us that a quadratic equation has 2 roots, such that one root is p times the other. We need to find the value of k in the equation. Pause the explainer again, but listen to me carefully. Do not try to solve this quadratic equation using the standard quadratic formula. Please, it is a massive, massive time sink.
Instead, we're going to use the recipe shortcut. Think about it like baking. You don't need to bake the whole cake to know what's in it, right? You don't need to find the exact roots. You just need the ratio of the ingredients. Let the roots be r and pr. We use Vietta's formulas. Step 2, write out the product of the roots formula, which gives us an equation for r squared. Step 3, write out the sum of the roots formula, which gives us an equation for just r. Now, simply square your r equation, set it equal to your r squared equation, and isolate k. It really is that straightforward.
This is Vietta's shortcut in action. Whenever roots have a defined relationship, like one being p times the other, or one being double the other, immediately use the sum and product of roots. You completely bypass solving the equation entirely. This pattern recognition trick is a ridiculous time saver for any high-level competitive exam.
And finally, section 5, coordinate geometry, the fork in the road. We've officially made it to our final challenge. Here's the scenario. A line with slope m intersects another line segment AB at an angle of exactly 45 degrees. We need to find the possible values of m. So take a moment, pause, and think about the formula for the angle between 2 lines. There is a very specific mathematical feature in that formula that acts as a huge trap for the unwary. Do you know what it is? Let's walk through it. First, calculate the slope of line AB using the given coordinates. That part is just standard stuff. Next, set up the tan theta angle formula. But now, look really closely at step 3. Because the tangent formula uses an absolute value, it literally creates a fork in the road. You cannot just solve the equation once. The tangent of 45 is 1, sure, but because of those absolute value bars, the expression inside could equal positive 1, or it could equal negative 1. You absolutely have to walk down both paths.
And that is the core concept here, absolute value angle cases. You must always evaluate both the positive and negative cases to find all the possible slopes. In this specific problem, one path gives us a slope of -3, and the other path gives us 1/3. If you only check one of those paths, you're gonna lose the points. No question.
So, let's quickly recap what we've accomplished in today's explainer. We conquered number theory with odd-even separation. We bypassed those algebra traps with mean-median manipulation. We literally crossed the geometry bridge with the extended sine rule. We saved massive amounts of time on quadratics using Vietta's formulas. And we totally avoided the coordinate geometry absolute value trap. Notice a theme here? Conceptual thinking and pattern recognition conquer all of these, period. Now that you have these high-yield shortcuts in your toolkit, I want to leave you with a provocative challenge. Are you ready to tackle 10 more of these without solutions? Keep practicing, keep recognizing those patterns, and I will see you in the